Okay, let's tackle some fractions. So let's start off by talking about what fractions are. Okay, fractions are also referred to as rational numbers. So if you hear rational numbers, that just means they're dealing with a fraction. That's all it means. There's a base word, in here, ratio, and a ratio is a comparison of two numbers. Comparison of two numbers. Okay, so if we're dealing with fractions, fractions are in the form numerator over denominator. And for a fraction, the key to a fraction, or the most important piece of a fraction, is this piece right here. Okay, your denominator is the most important piece. If you are adding or subtracting, the denominator has to be the same. If you are dividing, the denominator is the number that goes outside of your division symbol that you're actually working with. The denominator is by far the most important part of the fraction. So just keep that in mind. When you're flipping your fraction in order to do a division, something I like to tell my students is if you're doing numerator over denominator, okay, so in order to flip this to actually do long division, it's alphabetical. A lot of math is alphabetical, so you flip it this direction. So it's always D before N, okay? So that's alphabetical, denominator, and numerator. Remember, for division or fraction, this is called a fraction bar, okay? It's also referred to as per. So if you have a number that's over another number, such as 80 over 100, this would be 80 out of 100 or 80 per 100. So this is an example of a ratio or a fraction, okay? For fractions, what I want to focus on for this video is multiplying fractions. So something important about multiplying fractions. Okay, multiplying fractions. So something you need to remember or realize is you do not need a common denominator. So no common denominator necessary. Sometimes people go through and find a common denominator before they multiply. That's just a lot of extra work. As long as you don't make an excuse or as long as you don't make a mistake, that's what I'm trying to say. As long as you don't make a mistake, you'll still end up with the same answer, but you're creating a much bigger problem than is necessary. So there's no reason to find a common denominator. To solve, you have two choices. Your first option, let's go with option. Option number one is to multiply across and then simplify. I call this the old school method because this is the way I learned how to do it. You just multiply straight across, numerators, denominators multiply across, and then you simplify to get your final answer. The new method I like, it's probably not new, but newer to me. Option number two is to simplify first, and you do that by cross simplifying. And then multiply across. Then multiply across. And honestly, I used to hate fractions when I was growing up, and I'm still not a big fan of fractions, but as you understand fractions more, it'll make more sense, and then you can actually just whip through these without even thinking about them. But I choose option number two if I can at all simplify in the problem. but both options work. So the first few problems I want to try, I'm going to show you both options, and then I'll probably stick with option 2. If you get in the habit of doing option 2, it's going to make work a lot easier for you. There's a lot less work to show, a lot less multiplying and dividing in your head or having to do side work on your paper because you're dealing with smaller numbers if you simplify first. Okay, so let's try a few practice problems. Okay, let's start with something simple. Let's go with 1/3, and we're going to multiply that by 6/5. Okay, so again, I told you that you have 2 options. So to do option number 1 versus option number 2, I'm just going to work here in this space. So option number 1, again, was to multiply straight across, and then we're going to simplify. And we multiply the numerators. So these 2 get multiplied, and then your answer goes in the numerator space. And then multiply the denominators, and the answer goes in the denominator space. So 1 times 6 is 6. 3 times 5 is 15. At this point, you have to be really good with your factors. So factors are numbers that go into other numbers. So we need to look for a factor that goes into 6 and 15. Again, this is a fairly simple problem, so should be fairly straightforward. But we're going to divide both of these numbers here by 3. So if we divide 6 by 3 and divide 15 by 3, we're going to end up with 6 divided by 3, which is 2. 15 divided by 3, which is 5. And 2 is prime, 5 is prime, so this is a simplified fraction, 2/5. Okay, so if we're doing option number 2, again, I'll write out the problem. 1/3 times 6/5. And simplifying in the problem, what you want to do is you want to look at cross simplification. So that means that I'm looking for factors that I can simplify diagonal. So 1 and 5 are already simplified all the way down. 1 is 1. It's technically prime. 5 is prime. They are not going to simplify any more than that. So you can't get 1 to simplify farther down and still be a whole number. So let's look at 3 and 6. So if I look at 3 and 6, I can simplify these. And basically, you're going to see it's going to get us to the exact same spot. But I'm doing this step here, this divide by 3, in the problem. So 3 and 6 have 3 in common. So we're going to divide both of these by 3. And 3 divided by 3, I'm going to cancel that out, is going to simplify down to 1. And 6 divided by 3 is going to cancel out, and this is going to equal 2. And then you just multiply across. So I have 1 times 2, which is 2. I have 1 times 5, which is 5. So 2/5 is my final answer. Okay, let's try another one. Let's find one that actually will simplify for you. Let's do 7/8, and we're going to multiply that by 32 over 49. Okay, so again, if I'm going to do option number 1, I'm just multiplying straight across. Option number 2 will be to simplify. And this problem will probably show you why that option number 2 is so much more helpful for you. But again, it just takes a lot of practice. You just need to get into the habit of practicing. So let's do the multiplication straight across here. So I have 32 times 7. This is 2 times 7 is 14. Carry the 1. 3 times 7 is 21. Plus 1, 22. So this is 224 for my numerator. And then 8 times 49 is going to be 9 times 8 is 72. And 8 times 4 is 32, plus 7 is 39. So 392. All right. So then if we look at these two numbers, we should be able to simplify them. And we know that we can simplify them because they're both ending in an even number. So at the very least, I can cut each of these in half in order to make them smaller, which is what I'm going to do. I'm going to divide both of these by 2, and we'll see if we can go farther than that. So if I divide both of these by 2, so if I cut 224 in half, I get 112. Again, 224, divide that by 2. 2 goes into 2 once, leaving me a 0. Bring down my 2. This goes in once again. Do my subtraction. Leaving me 0, bring down my 4. 2 goes into 4 twice. No remainder. And at this point, we don't have remainders anymore since we're dealing with pre-algebra and algebra typically are not going to have remainders. All right, so that's 112 over 392. Let's cut this one in half. So 2 goes into 3 once. Do the subtraction, bring down my 9. 2 goes into 19 9 times, which is going to be 18. 2 times 9 is 18. Do my subtraction, bring down my 2. 2 goes into 12 6 times, which is 12. No remainder. So this is going to be 112 over 196. Well, again, that should simplify again down, divide both of these by 2. And I typically don't like to work this close to other problems, but that's okay. I'm trying to show you the difference between the two and how much time this side is going to save you if you actually practice that. So let's cut 112 in half. So 2 goes into 11 5 times. Really important that you put it over this one, not this one. If you put it over this one, it means that 2 goes into 1 5 times. So it needs to go over 11 5 times. Do my subtraction. Bring down my 2. 2 goes into 12 6 times. That is going to be 56 over, let's do 196 divided by 2. 2 goes into 19 9 times, which is 18. Bring down my 6. 2 goes into 16 8 times. So this is going to be 98. Okay, once again, you see that those are both even numbers, so I can divide again by 2. So let's do that. Go here, 56. Oh, you can't see that one's off the board. 56 divided by 2 goes in twice, which is 4. Bring down my 6. 2 goes into 16 8 times. So this is going to be 28. And then 98 divided by 2. 2 goes into 9 4 times, which is 8. Bring down my 8. 2 goes into 18 9 times, which is 18. So this is going to be 49. Now, I have to look at 28 and 49 and see if there's a number that they have in common, another factor, which they do. You can divide both of these by 7. So if I divide 28 by 7, I get 4. And if I divide 49 by 7, I get 7. So my final answer is 4/7. So this is a lot of work to get from here, this was my original problem, to my answer, which is here, 4/7. Okay, so yes, you could have gone and divided this by 4 if you realized that 4 went into 392, or you could have divided by 14. There's a lot of factors that you should see in here that would work, but this is the long route to take in order to get there. All right, so now if I'm going to use the simplifying method, look how easy this is. This is awesome. And I'm going to continue to work in this space right here. It's going to be really small, but this is going to be the square that we're going to work in. Okay? All right. So remember, like we did up here, you're simplifying diagonal if you can. And I purposefully set this problem up so that you can. So 7 and 49 can both be divided by 7. So if I divide both of these by 7, 7 divided by 7 is 1. 49 divided by 7 is 7. And then 8 and 32 can both be divided by 8. Divide by 8, divide by 8. 8 divided by 8 is 1. 32 divided by 8 is 4. Okay, you with me? So I have 1 times 4, which is 4. 1 times 7, which is 7. That is all the work that's required if you simplify in the problem, which is option number 2. Okay, I hope that makes sense. And how is that set up correctly there? Oh, it is set up correctly, I guess. Okay, I hope that makes sense, and I will record another video with a bunch of problems that we can try together. So look for that video, and good luck with your math practice. Thanks.